In this example, we'll sketch the graph of the rational function 3x plus 6 over x minus 3. To do this, we need to find the y-intercept, the x-intercepts, the vertical asymptotes, and the end behavior. To find the y-intercept, we want to look when x equals 0. Evaluating our function when x equals 0, we get 3 times 0 plus 6 up top and 0 minus 3 down bottom. This gives us 6 over negative 3, which is negative 2, so we have the y-intercept 0, negative 2, which we can plot on our graph. To find the x-intercept, we need to look when y, or our function, is 0. This gives us the equation 0 equals 3x plus 6 over x minus 3. But for a fraction to be 0, we need the numerator to be 0. In this case, we need to solve 0 equals 3x plus 6. If you'd like to see the steps of this done out, you can click the link to the left now. Solving this by subtracting 6 and dividing by 3, we find that x equals negative 2. So the x-intercept is the point negative 2, 0. Now, for the vertical asymptotes, we want to know when our denominator is 0. X minus 3 equals 0. But we can easily solve this by adding 3 to both sides of our equation and getting that the vertical asymptote is at x equals 3, which we can put on our graph. Now for our end behavior, we want to look at what our graph is doing as x goes to positive and negative infinity. We saw that since the numerator is going to act like 3x and the denominator just act like x for large values of x, 3x plus 6 over x minus 3 will act like 3x over x, which can be reduced to 3 over 1, which is just 3. In general, we saw that if the numerator and denominator have the same degree, then our end behavior is that f of x acts like the lead coefficient up top divided by the lead coefficient down bottom, in this case 3 over 1. So this means our function looks like the line y equals 3 as x gets larger and larger, either in the positive or negative direction. We call this a horizontal asymptote. Now, like polynomials, we need to check if our function f of x is bigger than 0 or less than 0 on some of our intervals. Because since there are no more x-intercepts, we know that f of x can only change sign at our x-intercept or at our vertical asymptote. Now between our x-intercept negative 2 and the vertical asymptote at x equals 3, we must pass through the point 0, negative 2. But since the y value at 0, negative 2 is negative, the y values must be negative for all the values between x equals negative 2 and x equals 3. And since we have a vertical asymptote at x equals 3, our y values must be going off to negative infinity. And to the left of negative 2, our y values need to be getting closer and closer to our end behavior, y equals 3. What about to the right of x equals 3? Here, we know our end behavior is that our function looks like y equals 3 for large values of x. And that as x gets close to 3, our y values either go off to positive or negative infinity. But we must be in the case where our y values go off to positive infinity. Because if our y values went to negative infinity, we'd have to cross the x-axis to get from negative infinity up to y equals 3, our end behavior. So using this information, we now have the graph of f of x equals 3x plus 6 over x minus 3.